Students, we're going to get underway with our Test 4 review and study guide. Of course, when we're thinking about Test 4, I got my little hand over here. When we're thinking about Test 4, we're thinking about Lesson 13, where we had to do with quadratic functions. We're thinking about Lesson 14, where we're talking about polynomial and rational functions. Now, of course, Lesson 15 had 3 parts. The first one was exponential functions, logarithmic functions, and solving equations and models. Now, if you'll notice over here, we have a little visual of one of the tiles I was using in the introduction to quadratics. And if you notice, we need to know what the function's about, the actual writing of it, and the graph. Domain, range, y-intercept, x-intercept. Now remember, that x-intercept and that x-intercept, they are zeros of the function. And remember, since this is opened up like a bowl, that would be the minimum. And the minimum has an x and a y. The x in this case is 1, that's the h, and then the y in this case is -2. So the minimum would be -2. All right, that's a quadratic function. Then we moved to the next level, which was polynomial functions. And polynomial functions are of a higher degree. So this was x squared. Now we have x cubed, x to the 4th, and so forth. And here is a polynomial function that's factored, and here it's just given to you. Now if I ask find the zeros, you want to break it down into all of the factors. So x cubed is x times x times x, and x minus 5 is x minus 5 times x minus 5, because I got it squared there, right? The zeros would be 0, 0, 0, 5, and 5. So really the zeros are 0 with multiplicity of 3 and 5 with the multiplicity of 2. Now if you notice down here on this problem, to find the zeros, that is the values where the function is crossing the x-axis, yes, you'd have to factor that. Now this right factor does not break down anymore. Matter of fact, if you tried to solve it, it would be an imaginary number. But this left factor does break down into x plus 1 and x minus 1. So the zeros for that function would be -1 and 1. Then we talked about exponential functions, and exponential functions really are a neat function. And we explained the general one, y equals 2 to the x, and I made a table, and I made the graph, and I explained the domain was all real, the range was y is greater than 0, it had an intercept of 0, 1, and it was increasing over its entire domain. And of course, the horizontal asymptote is y is equal to 0. Then you may remember we made the switch from exponential to logs, and in the log function in this lesson we noticed that really the log function is the inverse of the exponential function. So here we have an x-intercept of 1, 0, and we have a vertical asymptote here, and I explained to you how to graph it. It's a lot easier to take a function and then change it to exponential form than make a table. So these are some things that may help you by just way of quick review. Now let's get on and let's do some actual review problems from the study guide. So here's question number 1. It says describe where the following function f of x is equal to 4x squared plus 24x minus 3 is increasing and decreasing. Okay, well let's see here. Let's get another color here, my marker. Where'd my marker go? Okay, so the first thing I need to do is, it would be a good idea to sort of get a feel for the graph of this function. All right, where is it increasing? That means going up this way, and where is it decreasing? It really is asking what domain values. Well, first of all, we know from just looking right here, it's opened up. Okay, and we also know that it changes from decreasing to increasing right at this vertex point. Remember, that's the vertex, which is h comma k. H comma k. So remember, to find h, we could do a complete the square procedure, but just remember negative b over 2a. Okay, so remember, this is a, this is b, and that's really all we need. So negative b over 2a, negative 24 over 2 times a, which is 8. Now, what is that value? That's going to be negative 3. So we know right there that that x value is negative 3. And we could plug it in here and find the y or the k, right? But really it's just asking, describe where the function is increasing and decreasing. So this curve goes like this, and this value right here is negative 3 something, okay? Okay. Now remember, I'll just get it, I'll try, okay, just get a different color. Here the function is decreasing. Then here it starts increasing. And the point that it switches at is right here, or negative 3. So you're just going to say this. You're going to say increasing from what? From x is greater than negative 3, and you're going to say decreasing for x less than negative 3. Okay? Now, remember interval notation, x is greater than negative 3, so negative 3 to infinity. And on this type of question, let's just use parentheses on the endpoints. Of course, decreasing negative infinity to negative 3. Okay, so that's how I'd answer that question. All right, let's look at the next question. Let's just take another color here, okay? What is a domain of the function f of x is equal to 9x minus 1 over x squared minus 3x minus 4? Now, the important thing to keep in mind is, you know, every line has, the top here is all real numbers. But the bottom, we have problems. You cannot have 0 at the bottom. So it's saying, what is the domain of the function? It wants to know what values do we not have trouble with. Well, if I cannot date this person, I have trouble with this person, but I don't have trouble with everybody else, okay? So actually, I would date a girl, but actually I'm married, so, but anyway. So, what we need to do is we need to see where the denominator is equal to 0. So x squared minus 3x minus 4 is equal to 0. All right. Can we solve this? We could probably solve this by factoring x what? Minus 4 and x plus 1. So, you know, you're trying to find the zeros of this quadratic. So negative 1 and 4. So you can't date these people, okay? But you can date everybody else. So the answer to the question is x cannot equal negative 1 or 4. So that would be the domain. All real numbers except those. All right, let's see. We got 9 minutes on this one, so I probably got time for another question. All right, solve this problem. All right, let me, I'm just kind of being inspired by Mr. Khan here, okay? Well, now, if you notice in this problem, we have the base 9 and we have the base 27. This is an exponential equation, but there is a base that I can use to make a 9 and a base for 27. That's 3 what? Squared. and that's 3 cubed. So what we're going to do is we're going to rewrite this equation, and we're going to say 3 squared to some power, which is x plus 1, and then over here we're going to say 3 cubed to some power, which is 2x minus 3. Now, this is something that's actually we're pretty familiar with. We could use the power rule. So 3 to the 2x plus 2 is equal to 3 to, remember, you're going to multiply that 3 by that and that, which is 6x minus 9. Now remember the properties we talked about. If that base and that base match, then we could just set the powers equal to each other. So 2x plus 2 is equal to 6x minus 9. And try to remember what I taught you. Move the smallest one, subtract that. So that's going to be what? 4x. Now let's move that minus 9 over here and add it. That would be 11. So here we have x is equal to 11 over 4, or what? 2.75. Okay? So that would be the answer to that. And the good news is you could plug it back in for here, check it on your calculator. I would do that when I'm done, okay, because of the interest of time. Okay, I think we're going to be able to get one more question in here. Find the vertex of the function blah. Okay, well, now you may remember we saw this function before. Okay, so here we go, 4x squared plus 24x minus 3. Now someone says, well, I'll just plug that in my calculator and get it. And yeah, you can. Okay. Now you know it's going to have this shape, right? Find the vertex. Well, the vertex is right here. It's h comma k. And remember, h, if we're having this particular form, h is negative b over 2a. So let's do that over here. H is equal to negative 24 over double A MCO, that's transmission, no, sorry about that. Double A would be 8. Okay, so that's a negative 3. So H is negative 3. Now we want to find the K. In order to find the K, we have to plug it in the formula. So 4 times something squared plus 24x minus 3. I didn't mean to do x. How do I erase that? I don't know how to erase that. No idea. Let's just scribble that out and say x. Okay, so what are we going to put in for x? Negative 3, right? Okay, so this is 4 times 9 plus, well, 24 times 3 is 72. That's a negative 72 minus 3. 36 plus 72, that's a negative 72 minus 3. That's just negative 36 minus 3, that's a negative 39. So what's the answer to the question? What is the vertex? What is h comma k? Negative 3 comma negative 39. Okay, that's the answer to that question. Now what we'll do is, we'll pause here for a second. Okay, so this is reviewing the problems 1 through 4. We'll do a separate video on the next one.